Earth has likely had its atmosphere for billions of years, while our companion moon is airless. But maybe the moon once had an atmosphere, too, albeit a temporary one. So probably moon had once blue sky? This is what we are going to discuss today. And also consider subscribing to my channel because one more subscriber is +1 intelligence quotient point. Eva. I know everything. Our orbiting satellite may have once had a thick atmosphere. 4 billion years ago, the moon was going through a rough patch. During this age, now known as the Late Heavy Bombardment, the moon, along with Earth, was being pummeled by asteroids. This had the effect of aggravating its core of liquid hot magma, the way a wound gets aggravated if you poke it one too many times. Lava exploded onto the moon's surface, leaving behind dark spots of volcanic basalt, cupped in the impact craters left behind by the asteroids. Now, analyzing samples of the basalt collected in the 1970s, two space researchers have discovered that those eruptions also released a whole bunch of gas. Looking at the composition of the basalt, Deborah H. Needham, of the NASA Marshall Space Flight Center, and Dr. David A. Kring, of the university's Space Research Association, were able to determine that those lava flows would have released carbon monoxide, oxygen, hydrogen, sulfur, and other gases from the moon's surface. Though much of that gas would have been lost to space. Some of it formed a temporary atmosphere around the moon. That layer of gas was about 1.5 times the thickness of the atmosphere on Mars, but still only about 1.5% of the Earth's atmosphere. Today's moon is covered in dead volcanoes and dark maria, or plains that consist of hardened lava. The lunar atmosphere is so thin it's not even technically an atmosphere. Instead, it's considered an exosphere, with molecules that are gravitationally bound to the moon but are too sparse to behave like a gas. The research, published in the journal Earth and Planetary Science Letters, reveals that ancient volcanoes about 4 billion years ago may have created an atmosphere that lasted for about 70 million years before eventually fading away. Calculations made by Needham and Kring show that enough gases were produced by these erupting lava flows to form an atmosphere, albeit a temporary one. The new study highlights a pair of major gas-producing regions, the Serengeti's and Imbrium basins, which were filled with lava about 3.8 and 3.5 billion years ago. Interestingly, these findings could influence the location of future lunar missions. As the researchers explain, not all of the water produced by these eruptions escaped into space. The total amount of water released during the emplacement of the Mare basalts is nearly twice the volume of water in Lake Tahoe, which is 150.7 trillion liters, said Needham in a press release. Although much of this vapor would have been lost to space, a significant fraction may have made its way to the lunar poles. This means some of the lunar polar volatiles we see at the lunar poles may have originated inside the moon. This work dramatically changes our view of the moon from an airless rocky body, to one that used to be surrounded by an atmosphere. More prevalent than that surrounding Mars today, Kring's findings, which came with help from NASA, research scientist Dr. Deborah Needham, may have important implications for future lunar missions. The research quantifies a source of volatiles that may have been trapped from the atmosphere into cold, permanently shadowed regions near the lunar poles and thus, may provide a source of ice suitable for a sustained lunar exploration program. We will return American astronauts to the moon, not only to leave behind footprints and flags, but to build the foundation. We need to send Americans to Mars and beyond, said Vice President Mike Pence, during the first meeting with the National Space Council. There's no definitive plan of when this will happen, but it may be sooner than you think. At least one scientist believes that by 2030, some people will call the moon home. There may be the possibility to have children born on the moon, said a scientist at the European Space Agency during a conference in September. You probably will ask, but, can we leave, and evaluate a colony on the moon? Back in 2000, NASA completed a $200 million study called the Roadmap to Settlement, in which they described the potential for a moon-based colony, in which habitats could be constructed several feet beneath the lunar surface, or covered within an existing crater, to protect colonists from high-energy cosmic radiation. They also outline the construction of an on-site nuclear power plant, solar panel arrays, and a number of methods for extracting carbon, silicon, aluminium and other materials from the surface. More recently, NASA has also confirmed the presence of water ice on the Moon, a critical ingredient for any self-sustaining colony. Most of it resides at the Moon's North Pole, but it's a fair amount, about 150.7 trillion liters worth. Assuming that the radiation problem could be addressed, it might also be possible to set up solar-powered farming enclosures. If we could start farming at the lunar North Pole, experts estimate that a 0.5-hectare space farm could feed upwards of 100 people. At the same time, however, there will be some considerable challenges. The Moon features a long lunar night, which could limit solar power and require a colony to withstand temperature extremes. The Moon is also low in light elements, namely carbon, nitrogen, and hydrogen. Low gravity could prove to be a long-term problem. As NASA's roadmap suggests, a colony on the Moon could help us prepare for a mission to Mars. It would probably be wise to set up, test, and train a self-sustaining colony a little closer to home before we take that massive leap to Mars. And indeed, Mars holds considerably more potential than the Moon. It features a solar day of 24 hours and 39 minutes, and a surface area 28.4% less than Earth's. The red planet also has an axial tilt of 25 degrees, compared to the Earth's 29%, resulting in similar seasonal shifts, though they're twice as long given that Mars's year is 1.88 Earth years. And most importantly, Mars has an existing atmosphere, significant mineral diversity, such as ore and nickel iron, and water. Actually, it has a lot of water. Recent analysis shows that Mars could have as much water underground as Earth. So, what do you think when it will be possible to call the Moon home? Comment down below your versions. And don't forget to subscribe to my channel. Remember, you have a lot of questions and I know twice as much answers.